Top 10 Fresh Finds proving Jupiter is a weird place. Number 10. Lightning strikes. In English-speaking countries, we say love at first sight. In France, they say coup de foudre, which literally means a lightning strike, because it used to be so sudden and mysterious. Over the millennia, lightning was profoundly unfathomable and was often seen as something to do with the gods. But we have to thank Benjamin Franklin in 1752 for taking the mystery out of the phenomenon. It was he who established beyond doubt that it was purely electrical in nature. It results from two electrically charged areas in the atmosphere equalizing themselves. Other planets are known or are suspected to have lightning, and strikes on Jupiter are the best understood. At first, Jupiter's lightning was thought to be very different from here on Earth. For some reason, the strikes in the gas giant only appeared to release low-frequency radio waves, whereas on Earth they range from low megahertz to very high gigahertz frequencies. However, in 2018, the Juno spacecraft solved that particular conundrum. Jupiter's lightning also emitted radio waves whose frequencies were low to high. It had purely been an error caused by previous craft's inadequate sensing equipment. However, there does remain one mystery. Lightning on the Earth is almost unknown at the poles, and its greatest concentration is in the equatorial regions. For some undetermined reason, it's the other way around on Jupiter. But then, Jupiter is virtually all gas, so that may have something to do with it. Number 9. Not so jolly. When Gustav Holst wrote his 7-movement orchestral suite The Planets in 1916, he nicknamed Jupiter as the bringer of jollity. There's nothing particularly jolly about the actual planet with its constant, violent storms though. However, until recently, it was thought to be composing music too. In 2018, the Juno spacecraft flew by Jupiter, breaching the gas giant's magnetic field. Suddenly, on NASA's speakers, there was a huge rush of roars and screeching. Sadly, Jupiter wasn't composing its own music. It was an entry phenomenon known as bow shock, rather similar to the sonic booms here when aircraft break the sound barrier, but this time with a spacecraft. The shock lasted 2 hours as the craft zipped towards the planet at 150,000 miles per hour. Number 8. A swell place to be. Jupiter's mass is 300 times that of the Earth's, but the Goliath wasn't always so Goliathan. The formation of the solar system is more or less understood. The primordial sun was originally orbited by a huge dust-filled cloud. Some parts were more dense than others and attracted more dust to them. These eventually coalesced into the planets as we know them now. In those early millennia, Jupiter was originally about 20 times Earth's mass, a fraction of its present size. Then, it stopped swelling. Why was that? It's thought that massive protoplanets, no longer with us, smashed into Jupiter. The force was so great that, rather than adding much mass to the planet, they injected energy as those invaders disintegrated. This slowed Jupiter's growth. Eventually, as the bombardments reduced in intensity, Jupiter started swelling again to its present form, where it contains 2.5 times more mass than the entirety of all the other planets put together. Having said that, the Sun is still 1,000 times more massive than its gassy offspring. 7. Juno. What those stripes are. No stars and stripes, but lots of swirls and stripes. Jupiter is astoundingly beautiful, albeit at a safe distance. Until 2018, no one knew the depth of these colorful bands. Were they just on the surface, or did they plunge way down? The Juno spacecraft, which orbited the planet every 53 days, answered this question. Amongst many other things, it measured gravitation. It tracked the bands and noticed that they had a greater gravity than the surrounding non-banded areas. Scientists built up a 3D image to form a gravity map of the planet. They found that the stripes descended to a depth of nearly 2,000 miles. The gravity maps may, following further analysis, give some clues as to one absolute mystery. Why is it that, below the flows, Jupiter's fluid interior behaved like a solid? Number 6. Going the wrong way. Sometimes, when you point a powerful telescope into the sky, you don't find what you're looking for, but find something else that's just as fascinating. This happened in 2017 when astronomers were searching for the theoretical Planet X, the anticipated ninth planet in our solar system. Its existence is theorized because there appears to be something tugging at our planets, causing very slight differences between observation and orbital theory. Planet X is theorized to be in the direction of Jupiter. Someone noticed something unexpected. Previously, 69 moons had been spotted orbiting the gas giant. They saw another 10. But there was something distinctly weird about 8 of them. The other 2 spin with Jupiter. These 8, however, were going in the opposite direction, against Jupiter's rotation. This motion is known as retrograde, from the Latin retrogradus, retro meaning backwards, and gradus meaning to walk. One, called veil to do, meaning illness, really isn't going to be very well soon. It's approaching a head-on with one of Jupiter's spin moons, and both are doomed. Number 5. Magnetic untidiness. If the Earth had a magnetic field like Jupiter's, our compasses wouldn't just turn, they'd be glued to the ground. Jupiter's magnetic field is 20,000 times stronger than ours. But it's weird. Before the Juno spacecraft visited in 2016, it was thought that Jupiter's magnetic fields were not dissimilar to the Earth's. North Pole near the northern axis and the South Pole near the southern one. However, Juno showed that it wasn't quite as tidy as presumed. The magnetic South Pole was indeed located near the geographical south, but the North Pole was, as it were, all over the place. There was a strange magnetic ribbon and fields that were so chaotic that they resembled a plate of spaghetti. Some parts had northern characteristics but with no southern counterparts, and bizarrely, there's a strong South Pole around the equator. The Earth's magnetic fields are generated by its molten iron core. On Jupiter, however, it seems that there's a swirling hydrogen ocean below the surface that does the job. Unraveling the mysterious magnetic fields of Jupiter may lead to understanding what's actually happening deep inside the planet. But at the moment, it's just educated guesswork. Number 4. A cold spot. Jupiter's famous Great Red Spot is not alone. From an observatory in Chile, scientists have noticed another area of colorful, swirling gas. But this one is very different in behavior from its companion. Firstly, it's about 200 degrees centigrade colder than the surrounding area. And although it's thought to be 1,000 years old, it keeps appearing and disappearing. At its largest, it's about 7.5 by 15,000 miles across. And at its smallest, it's simply not there. The Chilean scientists think it's associated with Jupiter's aurora. As we all know, the Earth's auroras, seen over the northern and southern polar regions, are caused by a magnetosphere interacting with the solar wind. With Jupiter, however, it's thought to come from 2 locations, from the moon Io and from charged particle currents rising from Jupiter's magnetosphere. When Jupiter's auroras are quiet, that's when the great cold spot disappears, and then when the auroras intensify, the spot comes back. This is a further indication that Jupiter's magnetosphere is highly unstable. Number 3. Not where we think it is. We all know that the planets of our solar system orbit the Sun, but that's not the whole story. Planets actually orbit the solar system's center of gravity. Usually, because the Sun is so massive, we think that's the center. It isn't. Jupiter, whose mass is 2.5 times the mass of all the other planets put together, also has a noticeable gravitational effect on the solar system. The solar system's center of gravity is actually somewhere between these 2 great masses, and both rotate round this center. Obviously, this gravitational point is very close to our Sun, as it is nearly 1,000 times more massive than the gas giant. Although we can consider that, relatively speaking, all the planets orbit the Sun, the reality is that it's doing a bit of orbiting too. Number 2. Hot stuff. Jupiter, as we've seen, is huge. Its diameter is nearly 90,000 miles or 140,000 kilometers. the Sun's diameter is only 10 times greater. In fact, scientists reckon that Jupiter is as large as any planet can possibly be. Although it would have to have 75 times more mass to fuse hydrogen and thus become a star like the Sun, it's only 30% less than a red dwarf, the most common type of star in our galaxy, the Milky Way. Jupiter actually emits more heat than it receives from the Sun. Some of that heat is caused by its constant shrinkage of about an inch each year. Contraction causes energy in the form of heat to be released. The remainder of its radiated heat comes from helium sinking to its center through the outer hydrogen layers. This releases potential energy as heat. To put it into perspective, however, the Sun actually gives off 1 million times as much heat as Jupiter. Number 1. Pentangles on Jupiter. On Saturn, there are 2 cyclones. They're neatly arranged, one at each pole. As Jupiter is also a gas giant, scientists predicted that something similar would be found there. But Jupiter is a planet, bizarrer than bizarre. In 2018, the Juno spacecraft photographed Jupiter's poles. Yes, there were storms there, but so weird that, at the moment, they defy explanation. At the South Pole, there was a cluster of 6 cyclones. In the middle, it measured nearly 4,000 miles across. It was surrounded by the other 5, each being between approximately 3.5 to 4.5 miles wide. Here's the weird bit. They formed a clear, geometrically accurate pentagon. At the North Pole, there were 9 storms, one in the middle, as before, surrounded by the other 8. And the final weird part, although all the cyclones, north and south, touched each other, they didn't affect each other. There's no mixing, no cross-disturbance at all. Almost as if they're discrete entities. No one has the slightest idea what's going on. Jupiter is definitely weird.